that is do analysis. Maps are more than just looking at patterns and relationships and trends with our own eyes. You can actually do things like I've done here. In this case, I've got, let's make north at the top. I've got a simple analytical tool in this ArcGIS platform called Trace Downstream. Like the name implies, and like probably you've done this in other contexts, what happens if we drop some water on Boulder or on Grand Junction or on Granby, etc.? Where does that water flow? So here I've done that for a place just west of Boulder, and I've loaded it into another component of, look, you've got arcgis.com. Sounds familiar? It's the same platform we've been using all day. And now I'm going to see that, oh, okay, I've got it in a 3D scene. So if the students don't understand the relationship between watersheds and terrain, if you put it in a 3D scene, which is a part of the platform, running in a web browser, no software required to install, I've got, okay, it's going to flow into the Platte, it's going to flow into the Missouri, on down to the Mississippi, and down to the Gulf of Mexico. So in this one tool, again, you've got quite a bit of capability here, and you've got how far is it, how long is it going to take to get to the Gulf of Mexico, and all of those things just by dropping a point on the map wherever you want it to go. Okay, so I'm going to zoom out a little bit so we can see. Oh, okay, I get it, Joseph. You've got it. Okay, ooh, look, the whole planet here. Ah, there it goes. And I've symbolized it so that it's a thick blue line so that it's easy to understand. Okay, so wow, that's pretty powerful. And that trace downstream tool takes about 30 seconds to run. After 30 seconds, you've got this blue line, and you can put it in a 2D or a 3D map. All right, folks. Now, last closing bits here. I know this has been kind of fast and furious, but I hope you're seeing that, wow, there's a lot of capability here. And the last couple of things I wanted to mention is that touching on what Janelle and some others were discussing earlier, I really believe that these tools are not just the mapping tools, but it's, hey, I'm going to study storm drains or urban greenways or water pollution or something else in my own community, and then I'm going to map it, and I'm going to analyze it, and then I'm going to produce the results that the educator can assess in a story map or in a dashboard or something that goes into the student's portfolio going forward, a digital portfolio. And along those lines, you can talk about location privacy, copyright, where does the data come from? And this spatial reserves data blog that I've got linked here, and I'll also put it in the chat box, is all about where can I find data, how do I know if it's any good, and societal issues that are really important. Location is inherently personal. So there's a lot of personal issues that go into mapping and location information. So I want students to be critical consumers of data, especially mapped data, because mapped data tends to be looked on as authoritative. Hey, that's a map. It's on the web. Therefore, I can trust it. Well, wait a minute. Let's have a conversation. So this blog, which I know sounds super boring, a data blog. Oh, I can't stand my excitement. You know what I mean? But it's actually quite relevant to what you and I actually care about. And all of the essays in there, which come out every week or two, are digestible conversation starters in class. Okay. I took this in an actual high school in Colorado. The point I'm making here is don't get too attached to the tools. The tools change, geotechnology evolves. Keep this tool at the forefront, spatial thinking, looking at change over space and time, and encouraging the students to ask questions about what's the relationship between this variable and this variable, and how can I understand it better? So don't get too attached to the tools. All these tools that I've showed today, they're going to be around in the future. It's not like some sort of niche little program that Joseph invented on his own laptop. Okay, this is used by Excel Energy. What's powering your computer right now? GIS. What you had to eat yesterday? Supply chain, GIS, RTD, etc. Right? Bus lines are all using the same system. So also I wanted to make sure that you knew that the lesson body, where you can dig into short lessons that invite you to, okay, I'm going to open a web map. Here's some guiding questions that I could use if I wanted to, but me being a creative educator, maybe I like some of those questions and I'm going to invent my own questions because I don't like questions 3, 4, and 5. That's fine too, but you've got the maps tied to the lessons all at your fingertips. And the community of people that are around the world and here in Colorado doing this kind of thing in the classroom, the reason why I mention this, that they're engaged, vibrant, and expert, they are, you're not alone, okay? You're not alone doing this. So that all being said, I wanted to mention one more thing, and that I'm going to share a screen. I'm going to stop sharing, but I'm going to show you this, and this is of interest to you, how to dig deeper and how to get it. Well, let me just do it right here. I'm going to scroll back up to my own contact information and take questions, comments, complaints, anything you folks have questions about. But yes, there's Sarah's asking, hey, Joseph, I'm not going to use Web Mercator projection, rightly so, if I'm doing a polar study. And that's one, there's two things you can, you can use a polar projection with these tools. Projection transformation has been a mainstay of geographic technology for a long time. So yes, you can project the data. Secondly, sometimes the 3D scenes are better because you can obviously, you've got no projection issues at all because it's all, that's a globe as well. So let me share the link for this story map, and I'm going to take off that little edit thing there and share that and make sure that that works. But anyway, thanks, Brianna, and thanks everyone at CAEE. Looking forward to engaging with you in the future. And again, folks, if this is intriguing, you know where to get a hold of me, but also pester Brianna and saying, hey, we want a deeper dive, and we can do that. Yeah, that works. The nonprofit program is as old as our education program. So Sarah's right. If you're K-12, public, private, or homeschool, all this stuff is free. If you're a university, there's a 99.9% chance that your university, technical, tribal, community college already has all the ESRI technology at their fingertips, and all you have to do is be a named user in that organization. If you're a nonprofit organization, you go to our nonprofit page and you get the nonprofit organization pathway into ArcGIS. Yes, do not pay a commercial price for this. If you're a private individual operating your own private consultancy, don't go there. Go with the nonprofit pathway, and I'll put the nonprofit link in here as well. But anyway, thanks. Good thing you're bringing that up. All right, folks. And again, the nice thing about these tools is that that these tools are accessible, and 75% of the things that I did today, you don't have to log in at all. If you log in, as Sarah's indicating, you have a lot more power. Then you can save your maps, you can share your maps, you can make story maps, you can, I just wanted to pull up this page, you can do a lot more things. But even level 1 with the Living Atlas of the World, the water balance app, I would start there and use that for several weeks, months. Get comfortable with, okay, interacting, zooming and panning, changing symbology, etc. This map here shows all of the USA K-12 schools that actually use the stuff that I'm talking about. And we have a big cluster here in Denver thanks to the Science Colorado and GIS Colorado and CAEE and other organizations. So the point is you're not alone. There are other educators doing this in the classroom. And so that's one thing I wanted to mention. I know this map is a little geeky. It's got the little red schoolhouses for each individual school. But the other one is, per Sarah's point, is you go to Sarah, go to esri.com/nonprofit to go to the nonprofit page. So we support, as I mentioned earlier, Jane Goodall Elephant Foundation, the Deforest Action People, E.O. Wilson's Half Earth Foundation, TNC, I mean, the wide variety of nonprofits around the world. So anyway, good question. I'm wearing my map tie, folks, in your honor, because I really have great respect for what the things that you are doing in the classroom. And again, I wish you all the best in the rest of your semester. I know there's a lot of disruption in education, and you folks are my heroes. You're living and breathing this. And another nice thing about these tools is that if you're teaching hybrid or online, it's the same thing as what you're doing in the classroom, right? You've got all the data's online, the software's online, the analytical tools, the story maps, the dashboards, and everything else I've talked about today. It's all actually online. Now, sure, if you're in a place where there's limited bandwidth, and I've taught this in, the rainforest in Costa Rica, you gotta, just like you have a mindset with other tools that you're using in the classroom. Okay, maybe I don't look at 50,000 water wells. Maybe I have the students look at 20 water wells, or you know what I mean? So you're scaling the amount of points, lines, and polygons that these web tabs are sort of slinging around based on, some bandwidth considerations, which I realize are quite real, and they're real in higher education too. So that's a consideration. But okay, Brianna's smiling at me, so I suspect I'm out of time. But again, folks, all best wishes to you, and let me know if there's anything I can do to assist you in your future journey.
Thank you so much, Joseph, and we'll be sending a follow-up email with all of the information on there. So it was awesome that you guys all were able to join us today, and I hope you have a happy Earth Day.